Compilers, Principles, Techniques, and Tools, Second Edition. International Edition. Compilers, Principles, Techniques, and Tools, and International Edition. Table of Contents. Introduction. The language processors. The structure of a compiler. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation, symbol table management, the grouping of phrases into passes, compiler constructor tools, evolution of programming languages, the move to the higher level languages, impact on compilers, the science of building a compiler, the modeling in compiler design and implementation, the science of the code optimization, application of compile technology, implementation of higher level programming languages, optimization for computer architectures, design of new computer architectures, programming translations, software productivity tools, programming language basics, the static and dynamic distinction, environment and state, static scope and block structure, explicit access controller, dynamic scope, the parameter passing mechanisms. The aliasing and summary and references. Chapter 2, a simple syntax-directed translator. Introduction. The syntax definition of grammars, derivations, parse trees, ambiguity, associativity of operators, precedence of operators. Syntax-directed translation. Postfix notation, synthesized attribute, simple syntax-directed definitions, tree traversers, translation scheme, parsing, top-down parsing, predictive parsing, as when they use epsilon productions, designing a productive parser, left recursion, a translator for simple expressions, abstract and concrete stacks, adapting the translator scheme, procedures for non-terminals, simplifying the translators, the complete programming, lexical analysis, removal of the white space and comment, reading ahead, constants, recognizing keyword and identifiers, a lexical analyzer, and symbol tables per scope, the use of symbol tables, and the intermediate code generation, two kinds of intermediate representations, construction syntax trees, static checking, and three address code, and summary of Chapter 2. Chapter 3, Lexical Analysis. The role of the lexical analyzer. Lexical analysis versus parsing, tokens, patterns, and lexemes. Attribute for tokens, lexical errors, input buffering, buffer pairs, centenars. Specification of the tokens, strings and languages, operations on languages, regular expressions, regular definitions, extension of regular expressions. Recognition of tokens, transition diagrams, recognition of reserved words and identifiers, completion of learning examples, architectures of the transition diagram-based lexical analyzer. The lexical analyzer generates lex, use of lex, structure of lex programs, conflict resolution in lex, the required operator, the finite automata, the non-deterministic finite automata, the translation and transition tables, acceptance of the input strings by automata, deterministic finite automata, and from regular expressions to automata. Conversion of NFA to DFA. Alright, a simulation of NFA, Efficiency of NFA simulation. Construction of an NFA from a regular expression. Efficiency of string processing algorithms. Design of a lexical analyzer generator. The structure of the generated analyzer and pattern matching based on NFA, DFAs for lexical analyzer. Implementing for lookalike operator. Optimization of DFA-based pattern matchers. Important states of an NFA. Functions computed from the syntax tree. Computing nullable. And first pose and last pose. Computing follow pose. Position. Converting a regular expression directly to DFA, minimizing the number of states of a DFA. State minimization in lexical analyzer. Trading time for a space in DFA simulation. Summary and reference. Chapter 4. Syntax analysis. Introduction. The role of a parser. Representative grammars. Syntax error handling. Error recovery strategy. And a context-free grammar. A formal definition of a context-free grammar. Notational convention. Derivations. Parse trees and derivations. Ambiguity. Verified language generated by a grammar. Context-free grammars versus regular expression. Exercise 4 section 4. Exercises. The writing grammars. Lexical versus syntactic analysis. Eliminating ambiguity. Elimination of left recursion. Left factoring. Non-context-free language construct. Top-down parsing. Recursive descent parsing. First and follow. Error 1 grammars. Non-recursive predictive parsing. Error recovery in predictive parsing. Bottom-up parsing. Reductions. Handling pruning. Shift reducing parsing. Conflicting during the shift reduce parsing. Introduction to error parsing. Simple error. Why error parsers? Items and the error zero automation. Lightzone automaton. The error parsing algorithm. Construct as error parsing tables. Variable prefixes. Exercise. More powerful error parsers. Canonical error 1 items. Construct error 1 set of items. Canonical error 1 parsing tables. Constructing LA error parsing tables. Efficient construction of the LA error parsing tables. Compaction of error parsing tables. Exercise for section 4.7. Using ambiguous grammars. Precedence and associative to resolve conflict. The dangling errors ambiguity. Error recovery in error parsing. Parser generators. The parser generator YARC. Using YARC with ambiguous grammars. Creating YARC lexical analyzer with lex. Error recovery in YARC. Exercise for section 4.9. Summary and references. Syntax-directed translation. Syntax-directed definition. Inherited and synthesized attributes. Evaluating an SDD and those of a parse tree. And evaluation orders of SDDs. Dependency graphs. Ordering the evaluation of attributes. S-attributed definitions. L-attributed definitions. Semantic rules with controlled side effect. The application of syntax-directed translation. Construction of syntax trees. The structure of a type. The syntax-directed translation scheme. Postfix translation scheme and parser stack implementation of the postfix SDTs and the SDTs with actions inside the productions, eliminating left recursion from SDT and SDTs for L-attributed definitions, implementing L-attributed SDDs. Translation during recursive descendant parsing, on-the-fly code generation, L-attributed SSDs, and LL parsing, bottom-up parsing of L-attributed SSDs. So exercise summary reference. 6. Intermediate code generation, variance of syntax trees, directed acyclic graphs for expressions, the value number method for constructing DAG. 3. Address code, addresses and instructions, quadruples, triples, static single assignment form. Types and declaration, type expression, type equivalence, declaration, storage layer for local names, sequences of declaration, fields in a code and classes, the translation of expressions, operations within expressions, incremental translation, addressing address element, translation of array references. Exercises for type exercise, type checking, rules for type checking, type conversion, overloading of functions and operators, type inference and polymorphic functions, an algorithm for unification, control flow, Boolean expressions, short circuit code, flow of control statement, control flow translation of Boolean expressions, avoiding redundant gotos, Boolean values and jumping code, backpatching, one-pass code generation using backpatching for Boolean expressions, flow of control statements, break, continue, and goto statement. Switch statement, translation of the switch statement, syntax directed translation of the switch statement, and next is intermediate code for procedure. Summary reference. Runtime environment, storage organization, static versus dynamic storage allocation, stack allocation of space, activated trees, records, calling sequences, variable length data on stack, access to non-local data on the stack, data access without a nesting procedure, issues with a nested procedure, a language with nested procedure declarations, nesting depth, access links, manipulating the access links for procedure parameters, displays, heap management, the memory manager, memory hierarchy of a computer, locality programs, reducing fragmentation, manual deallocation request, introduction to garbage collection, design goals for garbage collectors, reachability, reference continuing garbage collectors, introduction to a trace-based collection, a basic mark and a sweep collector, Bayesian abstraction, optimization mark and sweep, and mark compact garbage collectors, copying collectors, comparing cost, short pause garbage collection, incremental garbage collection, incremental reachability analysis, partial collection basics, generational garbage collection, the train algorithm. 7.8 Advanced topics in garbage collection, parallel and concurrent garbage collection, partial object reallocation, and conservative collection for unsafe languages, weak references. Summary and reference of Chapter 7. 8. Code generation. Issues in the design of a code generator. Input to the code generator, the target program, instruction selection, register allocation, evaluation order. The target language, a simple target machine model, program and instruction codes, and addresses in the target code, static allocation, stack allocation, and runtime addresses for names. Page blocks and flow graphics. Basic blocks, next use information, flow graphs, representation of flow graphs, loops, optimization of basic blocks, the DAG representation of basic blocks, finding local common sub-expression, data code elimination, the use of algebraic identities, representation of array references, pointer assignment, and procedure calls, resembling reassembling basic blocks from DAGs. A simple code generator, register and address descriptor, the code generation algorithm. Design of function getLeg, the people optimization, eliminating redundant loads and stores, eliminating unreachable code, flow of control optimizations, algebraic simplifications and reduction to in strength, use of machine idioms, the register allocations and assignment, global register allocation, usage counts, register assignment for outer loops, register allocation of graph coloring, instruction selection by tree rewriting, tree translation schemes, code generation by tilling on input tree, pattern matching by parsing, routines for semantic checking, general tree matching, the optimal code generator for expressions. All shows numbers, generating code from the labeled expression trees, evaluating expressions with an efficiency and sufficient supplying of registers. Dynamic program code generation, continuous evaluation, the dynamic programming algorithm. Summary and references for Chapter 8 and 9. Chapter 9, Machine Independent Optimization. The principal source of optimization, causes of redundancy. A running example, quicksort, semantic preserving transformations, global common sub-expressions, copy propagation, dead code elimination, code motion, induction variables, and reduction in strength. Introduction to the data flow analysis. The data flow abstraction, the data flow analysis schema, data flow schemas on basic blocks, reaching definitions, live variable analysis, available expressions. The foundation of data flow analysis. Semi-lattices, transfer functions, the iterative algorithms for general frameworks, meaning of data flow solutions, exercise for section 9.3, constant propagation, data flow values for the constant propagation framework, the means for the constant propagation framework, transfer functions for constant propagation framework, monotonicity of the constant propagation framework, non-distributivity of the constant propagation framework, interpretation of the result, partial redundancy elimination. The source of redundancy. Can all redundancy be eliminated? The rage code motion problems, anticipated expressions, the rage code motion algorithms, loops in flow graphs, dominators, depth first ordering, edges in a depth first spanning tree, back edges, and a reducibility, depth of a flow graph, natural loss, speed of convergence of iterative data flow algorithms, region-based analysis, region hierarchies for reducible flow graphs. So, overview of region-based analysis. Necessary assumptions about transfer functions. An algorithm for a region-based analysis. Handling non-reducible flow graph. Symbolic analysis. Affine expressions of reference variables. Data flow problems formulation. Region-based symbolic analysis. 10. Instruction level parallelism. Processor architectures. Instruction pipelines and branch delays. Pipeline execution. Multiple instruction issues. Code scheduling constraint. Data dependence. finding dependence among memory accesses, trade-off between the register usage and the parallelism, phase ordering between the register allocation and code scheduling. So the control dependency, speculative execution support, a Beijing machine model, basic block scheduling, data dependency graph, list scheduling of basic blocks, prioritized topological orders, global code scheduling, primitive code motion, upward code motion, downward code motion, updating data dependencies, global scheduling algorithms, advanced code motion techniques, interaction with dynamic schedulers. Software pipelining. Introduction. Software pipelining of loops. Register allocation and code generation. Do across loops. And the goals and the constraint of software pipelining. The software pipelining algorithms are scheduling a cyclic data dependency graphs, scheduling cyclic dependency graphs, improvement to the pipelining algorithms, modular variable expansion, conditional statement, hardware support for software pipelining. 11. The optimization of parallelism of locality, basic concept, multiprocessors, parallelism applications, loop-level parallelism, data locality, introduction to affine transform theory, metric multiply, an in-depth example, the symmetric multiplication algorithms, optimizations, cache inference, iteration spaces, construction iteration spaces from loop nest, execution order of the loop nest, metric formulation of inequalities, incorporating symbolic constant, controlling the order of execution, changing axis, affine array and indexes, affine accesses, affine and non-affine accesses in practice, data reuse, types of reuse, self-reuse, self-spatial reuse, group reuse, array data dependency analysis, transformation on BDD, representing relations by BDD, relation operations as BDD operation, using BDD's 4.2 analysis. Exercise summary and reference of chapter 12. A complete front end. The source language, main, lexical analyzer, symbol, tables, and types, intermediate code for expressions, jumping code for Boolean expressions, intermediate code for a statement, parser, creating the front end. This is a table of the contents of the compilers, principles, and techniques and tools. Second edition. Thank you for your time. See you next time.